Hello everybody, welcome back to my channel. Today we're going to embark the journey in SPSS, specifically in the tests of relationship. Without further ado, let's get started. When we talk about tests of relationships, there are two of them, the non-parametric and parametric test of relationships. But in parametric test of relationship, we could use the Pearson R, and then for the non-parametric, we're going to use the Spearman rank. What is the difference between Pearson and Spearman correlation? The Pearson correlation evaluates the linear relationship between two continuous variables. The Spearman rank, however, correlation coefficient is based on the ranked values for each variable rather than the raw data. Spearman correlation is often used to evaluate relationships involving ordinal values. However, in addition, the Pearson R is used when the data is parametric. For non-parametric, we're going to use the Spearman rank. But how can we check if the data that we have is parametric or non-parametric? Let's dive in here in our data. So the data here explains that aims to explain the correlation between the age, the year level, and the gender to the level of internet addiction and level of reading books. So let us see if the data here is parametric or non-parametric. We have to click first Analyze, then Descriptive Statistics, then Explore, then after we're going to input the data that we are aiming for finding out if it's parametric or non-parametric. Next, we're going to click to Plots and then check histogram and normality plots with tests. Then continue, click OK. So after this loading here, we're going to see the normality tests of the data that we had input by the Kolmogorov and Shapirovilk. As we can see here, it is indicated as 0.00, 0.00, 0.17, 0.063, 0.00, 0.00, 0.00, 0.022, 0.062, and 0.00. Since the data here is not labeled as equally 0.00, we can say that the data is non-parametric. How? Because if the data or the p-value here would indicate or greater than 0.05, that would indicate that the data is parametric. However, if the data is less than or equal to 0.05, we can say that the data is non-parametric. So you can see here for the year level, 0.0 and 0.0, that would indicate as non-parametric, the same as the gender. However, for the level of internet addiction and reading books, it is greater than 0.05. No, it's not. In the 0.22 that is for a level of internet addiction, it is 0.022. That would indicate that it is a non-parametric. So since we're talking about non-parametric test of relationship, we're going to use Spearman rank. How? First, we're going to click Analyze, then Correlate, Bivariate, then we're going to input the data that we're testing for relationship. Let's say, for example, the age and the year level and the level of internet addiction. Here, we're going to click this Spearman rank and then the two-tailed. It sounds and it looks okay, so we're going to click OK. As you can see here, the Spearman rank indicates 0.024. So how can we say if that is significant or not? So first of all, why would you use Spearman rank? Spearman rank correlation coefficient is a technique which can be used to summarize the strength and direction, negative or positive, of a relationship between two variables. The result will always be between 1 and -1. Rank the two datasets. The smallest value in the column will get the lowest ranking. We can label the sig here as the p-value, and the correlation coefficient here is the r value. What's the difference between the p-value and r value? The p-value would indicate if the relationship is significant or not. However, if the relationship is significant, the r value will indicate the test of relationship between the variables, if the relationship would be strong or weak or moderately strong, moderately weak, or whatsoever. So if the coefficient of correlation is -1 to -0.5 and 1 to 0.5, that would be a strong relationship. However, for the positive, that would be strong positive relationship. For negative, strong negative relationship. Then for the -0.5 to -0.3 and 0.3 to 0.5, that would be moderate. Next, -0.3 to -0.1, or 0.1 to 0.3, that would be weak, and -0.1 to 0.1, that would be none or very weak. In this case here, we have 0.277, so that would indicate that our data, or the relationship that we have in this parametric or non-parametric correlation, would be moderately positive. So since the value of p here is 0.024, we're going to reject the null hypothesis, or we can say that the relationship between the year level and the level of internet addiction is significant. So what if our data is non-parametric? How do we do that? Just the same. We're going to click Analyze, then Correlate, Bivariate, then we're going to transfer the data that we are testing for our relationship. Let's say, for example, the age and the level of internet addiction. Now we're going to click Pearson R, and then we're going to unclick Spearman rank. The same as two-tailed, then OK. So before we're going to dive into the table, let's first explain what is Pearson's R used for. The Pearson correlation coefficient R can take a range of value from +1 to -1. A value of 0 indicates that there is no association between the two variables. A value greater than 0 indicates a positive association, that is, as the value of one variable increases, so does the value of the other variable. So that basically explains what is Pearson R. So for decision rule for assessing if the test is significant for 0.05, as you can see here, we have the p-value of 0.636. Thus, we can say that the relationship between the age and level of internet addiction is not significant, because in the majority of analysis, an alpha of 0.05 is used as the cutoff for significance. If the p-value is less than 0.05, we reject the null hypothesis that there is no difference between the means and conclude that a significant difference does exist. But since that indicates for below 0.05, however, for over 0.05, that would indicate not significant. So the value here is 0.636. That indicates the relationship between the age and the level of internet addiction is not significant. However, we cannot see the relationship strong or weak if the relationship is not significant, so that would be useless here. So for decision, we're done for that. So that basically sums up the lesson for today. The Pearson R for the parametric and the Spearman route for non-parametric. Hope you have learned something today. See you in my next vlog. Thank you. Goodbye.